All right, so this is the Unit 5 review video. Remember, tomorrow's test is going to be on radicals, square roots. You've got this square root chart at the top of your paper, and that's the same square root chart you're going to see tomorrow. Okay, so it's on square roots. Here's your square root chart from 1 to 15. Those are the perfect squares. You'll be able to use your calculator, and we're going to have trig on this test tomorrow, in which you'll have to be in degree mode. You can do all radicals in degree mode, not a big deal. There's also Pythagorean theorem. So make sure your calculators are set on degree mode. Mine already is. Nope, I'm still in this highlighter thing, so let me get out of this. Hold on for 1 second. Let's see if I can close this part out. Okay, so when I get to the calculator, I'll show you, not a big deal. So the first one, simplifying radical 48. We're looking for the largest perfect square that goes into 48. I know it happens to be 16, but 16 times 3 is 48. The square root of 16 is just 4. There's no more radical left. Final answer is 4 radical 3. Number 2, you can multiply both of these radicals together to get the square root of 360. So I'm going to do it that way first. So this becomes the square root of 360. This would simplify into radical 36 times radical 10, in which the square root of 36 is just 6, and your final answer is 6 rad 10. The other option is to simplify the radicals first. This is the only one that I'm going to do in 2 different ways. So if I wanted to simplify the radical first, I realize that radical 18 is radical 9 radical 2. And I realize that radical 20 is radical 4 radical 5. Well, the perfect square of 9 is 3. The perfect square of 4 is 2. But now I've got to multiply my 2 red numbers together and my 2 radicals together. Same answer, 2 different ways to do it. One way is not better than the other. It's just whatever way you prefer. All right, so number 3. I know that 12 times 45 is a pretty big number, so I'm going to simplify these guys separately. Just my choice. You might want to do it differently. Negative 3 radical 4 radical 3 times 5 radical 9 radical 5. Square root of 4 is 2. Square root of 9 is 3. What comes out is negative 6 radical 3 times 15 radical 5. I've got to simplify this. I can't keep it like this. Negative 6 times 15, negative 90. Radical 3, radical 5, radical 15. Number 4, I realize that radical 36 is a perfect square. So instead of rationalizing, I'm just going to write the one big square root into 2 separate square roots. Because this is a perfect square, I know that 6 is going to come out. What's left up top is radical 24. But wait a second. Radical 24 is radical 4 times radical 6. We know that the square root of 4 is just 2. So I end up with 2 rad 6 over 6. But 2 sixes is the same thing as just 1/3. So I'm going to simplify this to 1/3 radical 6. The 1 is not necessary, but it's not wrong either. Okay. Number 5, square root 27 is not a perfect square. So in this case, I'm going to rationalize. I'm going to multiply both the top and the bottom by the square root of 27. The reason I'm doing that is because that makes the radical on the bottom disappear. So on the bottom, it just becomes radical 27. On the top, it becomes negative 9 radical 81. Well, what ends up happening is the square root of 81 is just 9, which means my numerator becomes negative 81, whoopsie, divided by 27. And this actually just simplifies into the whole number of negative 3. On the next one, I'm adding and subtracting. I'm looking for like radicals. Here I've got negative 9 radical 2's. Here I've got positive 1 radical 2's. That adds to negative 8 radical 2's. Here I have negative 1 radical 5 plus 4 radical 5, which adds to 3 radical 5. These are not like radicals. I cannot combine them. It's not multiplication, it's addition. There's your final answer. 75. 2 radical 25 radical 3. 108 minus 6 radical 36 radical 3. Square root of 25, square root of 36. Multiply 10 rad 3s minus 36 rad 3s. Well, those are both like radicals. The fact that they're like radicals, all I need to do is just combine them. Whoops, a little bit too high. Hold on. Let me bring this back up. Okay, so 10 minus 36 is negative 26, and we're talking about the square root of 3. Let's see here. Root 32 I can do something with. 7 root 16 root 2. And then 3 rad 45 I can do something with. 3 rad 9 rad 5. I haven't written the other stuff down yet because I'm not ready to use it yet. So now I'm going to write this stuff down. So my first thing becomes 28 radical 2 minus 5 rad 3 minus 2 rad 2. Those I couldn't touch. Minus 9 rad 5. Well, like radicals, you'd think there'd be more, but there's not. There's just rad 2 and rad 2. 28 minus 2 is 26 rad 2. Can't do anything with minus 5 rad 3. Can't do anything with minus 9 rad 5. That's your final answer. Multiply in. So when I distribute in, I get negative 30 rad 80 plus 42 rad 20. 80 goes into negative 30, 16 and 5. 20 goes into plus 42, rad 4, rad 5. 4 comes out, 2 comes out. This becomes negative 120, 5. This becomes 84, 5. They are like radicals. Final answer is negative 36, 5. This next one I need to FOIL. So this becomes 4 rad 25. This becomes negative 14 rad 15. This becomes positive 14 rad 15. This becomes negative 49 rad 9. When I combine like terms, first of all, I should realize that these completely disappear. They're inverses of one another, they're opposites. A 5 comes out of there, a 3 comes out of there, and I get 20 minus 147, which equals negative 127. Okay, so that's all radical stuff. Now we're moving on to trig stuff. Remember, you must be in degree mode. Use your calculator to find the following values. Round to the 10,000th place. If it's angles, round to the nearest degree. 10,000th place is 4 places over. You look at the 5th, it tells you how to round the 4th. Sine 53, type in exactly what you see. You get 0.7986 when rounded appropriately. Cosine 27 in the calculator is 0.8910. Tan 38 is 0.7813. If you're trying to find the measure of an angle, I'm going to type in second sine, and then I'm going to put in, this case, the decimal. What comes out is going to be 43 degrees. Second tan comes out to be 40 degrees. Okay, for these next few, setting up the trig. Find the missing measure. Each sides are now going to the nearest tenth. So sides go 1 decimal place Angles go to the whole degree. I'm looking for an angle. I've got my opposite side and my adjacent side. This becomes the tangent of x equals 2 over 4. Just to kind of show you again what gets plugged in here. The fact that I'm finding a missing angle, it's going to be a second tan. So I'm looking for second tangent. And again, it's 2 divided by 4. You should close up the parentheses. You don't have to on this one, but you should get into the habit. This comes out to be 26.5 degrees or 27 degrees when rounded to the nearest whole degree. So this becomes x equals 27 degrees. This one, I'm given the angle of 32. This is my hypotenuse. This is my adjacent. This is a cosine. So cosine of 32 equals adjacent over hypotenuse. When I cross multiply here, I end up getting cosine 32 of x, or times x, equals 20. I have to divide out both sides by cosine 32, cosine 32. So really all that you're typing in on the calculator is 20 divided by cosine 32. Round this to the nearest tenth, it should be 23.6. Okay. Take a look at this next one, 18 degrees. This is the hypotenuse. This is going to be the adjacent. This is another cosine. Cosine of 18 over 1 equals x over 13. This is just a straight cross multiplication, and when you do that and round to the nearest tenth, you get 12.4. This guy, hypotenuse opposite. Here's a sine. Sine 27 over 1 equals 3 over x. I've got to cross multiply and divide. So essentially when I do that, what I'm putting into the calculator is 3 divided by sine 27, and this comes out to be 6.6. Now we start doing some word problems. A support wire for a light pole forms an angle of 62 degrees with the ground / the angle of elevation. If the pole is 60 feet high, how long is the wire? Drawing a picture, you can just draw a triangle. I'm actually just going to draw my pole with the ground and then my wire. So a support 62 degrees angle of elevation. The pole is 60 feet high. How long is the wire? They want the hypotenuse. So what's happening here is I've got my opposite, my hypotenuse, or sine 62 over 1 equals 60 over x. Cross multiply and then divide, because really you're going to be having to do 60 divided by sine 62. That comes out to be that the wire happens to be 68.0 feet. Remember, once to the nearest tenth for sides, so 0.0 has to be there. You don't need to label it in feet. It'd be great if you do, but it's not necessary. On this one, suppose a person is standing on top of a 152-foot lighthouse, spots a boat in the water below. The angle of depression is 9 degrees. Find the distance from the foot of the lighthouse to the boat. Complete the picture. So that means the angle of depression is really here. Okay, that's the 9 degrees. This is the boat. You don't have to draw that. Here's your lighthouse. The lighthouse we know is 152. It wants you to find the distance from the foot of the lighthouse to the boat, which is here. So this is going to be an opposite and an adjacent. It's a tan. So you're getting tangent of 9 equals 152 over x. You're going to cross multiply, divide, and solve. X becomes 959.7 feet. Next one. Joe is holding a kite string 3 feet above the ground, as shown in the accompanying diagram. The distance between his hand and the point directly under the kite is 95 feet, and it's showing you that. If the angle of elevation is 50, it's showing you that. Find the height of the kite. Now, what you need to understand is the measures that you're dealing with are really only from here to here to here. Okay, so in that setup, we know that this becomes the opposite, this becomes the adjacent because here's your angle. So what we're looking to do is tangent. Tangent of that 50-degree angle over 1 equals the opposite over the adjacent. When you cross multiply, you get x to be, this one's to the nearest foot, not to the nearest tenth. X is about 113 feet. But that's not the answer, right? Because why this is 113 feet, don't forget that this distance right here is an additional 3 feet. So how high is the kite off the ground? Well, the 113 plus the 3 extra feet, it really becomes 116 feet. This, I think I gotta go on to full page here. All right, so we're looking for the sine of P. Here's P, sine, and again, we'll have this up for you for tomorrow. I would imagine you have it memorized anyway. So I'm looking for opposite over hypotenuse. The sine of P is 9 over 15. But you know what? 9 over 15 is not given. They must have simplified it. 9 over 15 is 3/5. Tangent of Q. If I'm at Q, this becomes opposite over adjacent. This becomes 12 over 9. Well, that's not there either, but it's been simplified, and you simplify it to 4/3. Cosine of Q. Now I'm back at Q, and now I want to do adjacent over hypotenuse. So now I'm doing 9 over 15. Simplify that to be 3/5. What is the measure of angle P to the nearest whole degree? Well, I'm actually going to go back here, and I'm going to say, okay, well then I'm going to use my sine of, or second sine I should say, sine -1, second sine, and I'm going to type in either 9 divided by 15 or 3 divided by 5, either way, and I get choice 2, 37 degrees. All right, so that's it. I'm pretty sure you guys will all do great tomorrow, and I will see you then.